choose the curve y equals sine 2x cos square x for x in between 0 and pi over 2. M is a maximum point. Part A, use the substitution u equals sine x to find the exact area of the region bounded by the curve and the x-axis. So we just need to find the region, the area of the region under this curve. And in order to find the area, we integrate the curve, which is sine 2x cos square x with respect to x from 0 up to pi over 2. And we are to use the substitution u equals sine x. If u is sine x, du dx is cos x, or du is cos x dx. Now let's look at the integrand. Yes, sine 2x here. So we have to expand this using the double angle formula. Also, the limits, the lower and the upper limits has to be changed. When x is 0, u is sine 0, which is 0. When x is pi over 2, u is sine pi over 2, which is 1. So we change the limits to 0 and 1. And we need to change the integrand as well. Sine 2x is given by 2 sine x cos x, and we have cos square x dx. We need a cos x dx to change to du. We have a dx and cos x here. So we integrate 2 sine x cos square x, and we have cos x dx. That changes to du, and u is sine x. We have cos square. So we use the fundamental identities of trigonometry, change cos square to 1 minus sine square. Then the integrand becomes 2 sine x, 1 minus sine square x, and we have cos x dx. Now we perform the substitution. So we are integrating from 0 to 1 instead, and sine x is u. We have 1 minus u squared and du here. So that becomes 2u minus 2u squared. And upon integration, we have u squared minus 2, sorry, this is 2u cubed, minus 2 over 4. So that becomes 1 over 2, u to the 4, evaluated from 0 to 1. We replace u with 1, that is 1 minus 1 over 2, and we sub in 0 for u, that is just going to end up 0. That will give us 1 over 2 square units for the area. Part B, we need to find the exact x coordinates of M. This M is a maximum. At the maximum, dy dx is 0. So we need to find dy dx first. Y is sine x times cos square x. To find dy dx, we need to use the product rule. So we can hold sine 2x and differentiate cos 2x. So that becomes 2 cos x minus sine x. Now we hold sine 2x. Now we differentiate sine 2x. So when we differentiate sine 2x, that becomes cos 2x. And when we differentiate 2x with respect to x, we have a 2 here. And we have cos square x. So dy dx here, let's have a look at this. You can see that there's a 2 here, there's a 2 here, which is common. And also, there is a cos x and there is a cos x here. So what we could do is we can factor 2 cos x. And let's look at this. When we factor 2 cos x, we will have cos 2x cos x here. This is a negative, so we are negative sine 2x sine x. That is dy dx. Maximum occurs when dy dx is 0. So we set dy dx to 0, which implies that 2 cos x, and then we have cos 2x cos x minus sine 2x sine x, and this is set to 0. Cos 2x and sine 2x has to be written in terms of x. We apply the double angle identity. So pull out the cos x here. This is the cos x. Cos 2x is 2 cos square x minus 1. And then we can pull out the sine x. And sine 2x is 2 sine x cos x. This is equals to 0. Now let's look at this. You have a cos x and you have a cos x. You can factor so that you have 2 cos square x. Then this cos x is gone. We're done. Then we have 2 cos square x minus 1 minus, that will give us 2 sine square x equals 0. There's a mixture of sine and cos here. We can use the Pythagorean identity. Cos square is 1 minus sine square. So we replace cos square with 1 minus sine square x minus 1 minus 2 sine square x equals 0. And this turns into 2 minus 2 sine square x minus 1 minus 2 sine square x equals 0. Collecting like terms, we have 1 minus 4 sine square x equals 0. Now, the product of these two is 0. So we have 2 cos square x equals 0, which will give us cos square x equals 0, which will end up cos x equals 0. But cos x is 0 when x is pi over 2. So that is not possible because this is pi over 2. The x coordinate of m must be less than pi over 2. Answer must be from this second part here. 1 minus 4 sine square x is 0. 4 sine square x is 1, or sine square x is 1 over 4. Taking square root, we have sine x equals plus minus 1 over 2. Since the x coordinate is in between 0 and pi over 2, sine x cannot be negative. Sine x must be positive 1/2 is in the first quadrant. And taking inverse sine, we have x equals inverse sine of 1/2. That will give us pi/6.